In this question, you've got two people who both buy a chocolate bar from a vending machine, and that sells an Aero, Bounty, Crunchy, or Dime. And you can see here that each one of these is just the first letter of the alphabet, first letter. So A, B, C, and D. And the reason they've done that is so that you can just write, instead of writing Aero, you just write the letter A. So to list the possible pairs of chocolate bars which you could choose, let's say that you've got Caitlin here and Dave here. This is a good way to present the data. So the first pair you could have is where they both get an Aero. And the second, let's do this logically. Let's say that Caitlin remains with the Aero and then Dave chooses a Bounty. Can you imagine what the next would be? Stick with the pattern, move the next one. Stick with the pattern, move to the next one. Now the one after this has to now change because we've done all of where Caitlin has A, and we've changed what Dave has in every case. The next one's is just going to be the same sort of pattern, but now we'll choose B for Caitlin, and we'll start with A for Dave, and B here, and this becomes B. B here, this becomes C. B here, this becomes D. So we can spot now that we've got 4 A's, A, B, C, D, 4 B's, A, B, C, D. And we will just repeat this over here with the next lot, which will be 4 C's with an A, B, C, D, and then 4 D's with an A, B, C, D. And now we know that we haven't missed any of them out. Just by going into this randomly, it's possible we could have missed one of these combinations out. But we know because we've done it methodically, we have all of the different possible pairs. Next, if you have a fair die, this should read die, dice is plural. A fair die is rolled and an unbiased coin is tossed. Unbiased means that it's even probability. So it's a 50-50 chance for either side of the coin. It's asking for us to draw a table to show the possible outcomes. So let's start off by just writing coin here. A coin could be a head or a tail. So that's that side of the table. You've got heads or tails like that. And then on the fair die, you've got 1, 2, 3, 4, 5, or 6. So we could, let's say we roll we flip the coin, we get a head, and let's say that we roll the die and we get a 1. Overall, then we'd have a head and a 1. And we can fill in this whole table in this way. So this would be a tail and a 1, a head and a 2, a tail and a 2, a head and a 3, a tail and a 3, and so on. So this is the most efficient way to fill in the table, to show you've got coins on one side and the die on the other. And that is the table, so it's as simple as that. Okay, the next example, we've got to draw a table to show the possible total scores when 2 fair dice are thrown at the same time. So we'd have die A and die B. And we can say on die B, 1, 2, 3, 4, 5, or 6. 1, 2, 3, 4, 5, or 6. And it's asking for the total score. So this is adding the two together. Here we would have a 2, it's a 1 plus a 1. Here we would have a 3 because it's a 2 plus a 1. And you can see that all of these will just go up in 4, 5, 6, and 7. If I picked a random one, let's say 3 and 4, if I add them together, I get 7. Let's do the last one, 6 and 6, that adds up to 12. And I would fill in all of these 36 numbers, and that would go all the way from 2 being the smallest and 12 being the largest. So there are 36 outcomes here, but I won't write them all in this video. Example 4, we've got to use a tree diagram to show the possible outcomes when 2 unbiased coins are tossed. A tree diagram is where you start off with a decision, and this decision is going to be for coin A. So we flip coin A, we could get a head or we could get a tail. And then we have to flip the second coin, which I'm going to call coin B. Well, after we get a head, we could get another head on coin B, or we could get a tail on coin B. Or if we got a tail on coin A and we flipped it, we could get a head on coin B or a tail on coin B. And the outcomes here would be a head and a head. I'm just following the tree here, and then we get a head and a tail. Or we could have a tail and a head, or we could have a tail and a tail. And these are all of the outcomes. In the final example, in a drawer there are some white socks and some black socks. We don't know how many of them there are. Tim takes out one sock and then a second. And we have to draw a tree diagram to show the possible outcomes. So, in the same way that we did with the coins, we'll say the first sock is going to be the first decision. And when we pull out the first sock, that could be a black one, or it could be a white one. We don't know. And then on the second decision is the second sock. That could be a black, or it could be a white. If we had a white one first, we could still either get a black or a white. And the outcomes will be a black and a black, or a black and a white, or a white and a black, or a white and a white. Easy. Give it a go.